Designing Empathetic Intelligence, the next frontier in human-centered AI. Human-centered AI, HCAI, emphasizes that artificial intelligence should not merely be optimized for performance, accuracy, or automation. It must be designed with a deep understanding of human needs, behaviors, and core values. Human needs. AI systems must address essential and evolving human needs across different domains. Physical needs, health monitoring, medical diagnostics, assistive devices. Cognitive needs, learning support, memory aids, knowledge access. Emotional needs, companionship, mental health support, empathetic interfaces. Social needs, inclusion, communication, cultural sensitivity. Brain example: AI-powered hearing aids that adjust based on the user's environment. And emotional tone. Human-centered AI, HCAI. Human behaviors. AI must adapt to the way people act, interact, and learn. Behavioral modeling, understanding patterns in speech, movement, and habits. Personalization, learning user preferences to customize responses. Adaptive learning, systems that evolve with user feedback and interaction. Example: an AI tutor that modifies teaching strategies based on a child's learning style and attention span. Human values. AI should be aligned with societal and ethical principles, ensuring it uplifts and respects individuals and communities. Fairness, no bias or discrimination in decisions of, for example, hiring, lending. Transparency, clear explanation of how AI decisions are made. Accountability, traceability of outcomes and responsibility. Sustainability, supporting long-term human and environmental well-being. Example: an AI hiring platform that ensures anonymized bias mitigated. Screening of candidates. Kant. 1. Symbolic AI in the 1950s, 1980s, good old-fashioned AI. Also known as logic-based or rule-based AI. Core idea: intelligence is achieved through explicit rules, logic, and symbols. Method: IF then rules, knowledge bases, ontologies. Strengths: transparency, explainability. Limitations: poor adaptability, brittle systems, no learning from data. Example: expert systems like Mycin for medical diagnosis. 2. Machine learning, 1990s, 2010s, data-driven intelligence. Core idea: AI learns patterns from data rather than rules. Method: supervised and unsupervised learning using statistical models. Strengths: high accuracy with large data sets, flexible across domains. Limitations: opaque decisions, bias inherited from data, minimal context. Awareness. Example: spam filters, image classifiers. Evolution of AI paradigms from symbols to humans. 3. Deep learning, 2012 present. Neural networks at scale. Core idea: mimic the human brain using multi-layered neural networks. Method: deep learning architectures like CNNs, RNNs, transformers. Strengths: state-of-the-art in image, voice, and language tasks. Limitations: black box models, data-hungry, energy-intensive, weak in reasoning. Brain example: ChatGPT, AlphaGo, DALL-E. 4. Human-centered AI, emerging paradigm, 2020s and beyond. Core idea: design AI around human values, emotions, and social context. Method: combining cognitive science, ethics, human-computer interaction, and participatory design. Strengths: trustworthy, inclusive, explainable, empathetic. Focus: human-AI collaboration, co-creation, emotional intelligence. Brain example: empathetic chatbots, AI companions for elderly care, accessible AI. Tools for disabled users. Con: human-centered AI (HCI) places people, not technology, at the heart of artificial intelligence design, development, and deployment. It ensures AI enhances human well-being, preserves dignity, and operates within ethical and social boundaries. 1. Centered on human values. Respect for privacy. AI must protect user data and autonomy. Fairness and inclusion. Avoid biases. Include diverse perspectives in design. Transparency and accountability. Make AI decisions explainable and traceable. Example: AI models that offer users the option to inspect how a recommendation was made. 2. Designed for human collaboration. Augmentation, not replacement. Assist rather than automate human tasks. Intuitive interaction. Interfaces should be user-friendly and natural, for example, voice, gestures. Feedback loops. Allow humans to correct or adjust AI decisions in real time. Example: a radiologist using AI to flag anomalies in scans but retaining final decision-making authority. Core principles of human-centered artificial intelligence, HCI. 3. Emotionally and socially intelligent. Empathetic interfaces. Recognize and respond appropriately to human emotions. Context-aware behavior. Understand social cues and adapt responses. Personalization. AI that adapts to individual users' needs and preferences. Example: mental health chatbots trained to detect distress and escalate to human help when necessary. 4. Inclusive and participatory design. Stakeholder involvement. Include end users, ethicists, and marginalized groups in AI development. Accessibility. Ensure AI tools are usable by people with disabilities. Low literacy or non-dominant languages. Example: speech interfaces that support regional languages or assistive AI. For the visually impaired. Cont: these pillars guide the design, development, and deployment of AI systems that serve human needs ethically and effectively. 1. Human agency and oversight. Definition: empower users with control, understanding, and the final say in AI-assisted decisions. Principles: human in the loop, HITL, or human on the loop, ITL mechanisms. Informed consent and choice in AI usage. Example: medical AI systems providing risk assessments but leaving diagnosis decisions to clinicians. 2. Technical robustness and safety. Definition: ensure AI systems are secure, reliable, and resilient to errors and adversarial attacks. Principles: fail-safe and fallback procedures. Continuous monitoring and validation. Example: autonomous vehicles trained to safely respond to unknown road conditions. The 5 key pillars of human-centered AI. 3. Fairness, inclusivity, and non-discrimination. Definition: avoid unjust bias and ensure equal access and benefits for all demographics. Principles: diversity in data collection, algorithmic audits, and fairness metrics. Example: recruitment algorithms designed to remove gender or racial bias. 4. Transparency and explainability. Definition: AI systems must be understandable, traceable, and open to scrutiny. Principles: clear model logic and decision traceability. Explainable AI XAI techniques like LIME, SHAP. Example: loan approval systems explaining why an applicant was denied credit. 5. Ethical purpose and societal well-being. Definition: AI must contribute to positive human outcomes and respect fundamental rights. Principles: environmental, social, and governance (ESG) alignment. AI for social good initiatives. Example: AI tools for climate modeling or disaster relief planning. CONT. Emotional AI, also called affective computing, refers to AI systems designed to detect, interpret, simulate, and respond to human emotions through data like facial expressions, voice tone, body language, and physiological signals. Key components of emotional AI. 1. Emotion recognition. Uses computer vision, voice analysis, and sensor data to identify emotions like happiness, anger, sadness, or anxiety. Tools: facial expression detectors, tone analyzers, EEG-based sensors. Speaking Head 2. Emotion simulation. Enables virtual agents, for example, avatars, chatbots, to respond empathetically using expressive voices, gestures, or words. DNA 3. Emotion adaptation. AI adjusts behavior dynamically based on the emotional state of the user. Example: an AI tutor slowing down when a student shows signs of frustration. Emotional AI aims to make machines more relatable and supportive, but its use must be ethically grounded, respecting human dignity and emotional boundaries. Emotional AI teaching machines to feel. Explainable AI XAI refers to AI systems that make their decision-making processes transparent, understandable, and interpretable to humans. Unlike black box models, for example, deep neural networks, XAI provides reasons behind predictions. Feature importance: logical transparency, user trust and accountability. XI, explainable artificial intelligence. In healthcare, AI decisions can directly impact human lives. Doctors, patients, and regulators must understand how and why a diagnosis or recommendation is made. Explainable AI XAI helps by making AI decisions transparent, building trust with doctors and patients, supporting accountability and ethics. Stethoscope use case: AI-powered diagnosis. Scenario: a deep learning model predicts a high risk of heart disease in a patient. Without XAI, the model predicts a 91% risk, but offers no explanation, raises doubt and risk. With XAI, risk is high due to elevated cholesterol, family history, irregular ECG pattern, high blood pressure. Doctors can validate, challenge, or combine with clinical judgment. XAI in healthcare explaining medical decisions. The bar heights show that all user groups preferred explainable AI, with clinicians showing the highest satisfaction, followed by students and patients. 1. Healthcare AI in Diagnostics. Study. Harvard Medical School and Mayo Clinic, 2022. Methodology. Randomized control trial with 280 physicians using AI-assisted diagnostic. Tools. With interpretability boosts accuracy, efficiency, and trust in clinical settings. Data-driven research findings in human-centered AI HSI. Metric. Black box Group A. AI Group B. Diagnostic accuracy. 72.4%. 88.1%. Physician trust score. 3.2/5. 4.6/5. Time to diagnosis. 11.5 mins. 8.3 mins. Acceptance rate. 48%. 77%. Key research directions in human-centered AI. Human-in-the-loop systems. Integrating human feedback during model training or inference. Fairness and bias auditing. Tools to detect and mitigate biases in AI models. Multimodal emotion recognition. COM-NG voice, facial, and physical. To understand emotions. Ethical trade-offs. Balancing accuracy, interpretability, and privacy. Considerations. Cognitive load detection. Adaptive systems that measure and respond to user cognitive states. Longitudinal user studies. Assessing changes in trust and interaction over extended periods. AI for non-technical users. Designing explainability methods suited for label. AI for social good. AI applications in areas like health, education, and disaster relief. Metric. 2025-2030 forecast. Its high adoption in healthcare. 38%. 76%. Percent of explainable AI models deployed. 22%. 60%. Public trust in AI systems. 43%. 70% plus with XAI. Emotional AI market size. $20 billion. $56 billion plus. Forecasts and insights. Why empathy in AI? Human interactions are emotion-driven. Current AI often lacks contextual and emotional sensitivity. Empathetic AI ensures better trust and acceptance. Improved user experience. Ethical decision-making. What is empathetic intelligence? Emotional perception, processing, and response in AI. Empathetic intelligence equals affective computing plus social intelligence plus human centered design. Linked to behavioral science, neuroscience, and linguistics. Affective computing and its role. Recognize, interpret, and simulate human emotions. Modalities. Facial expressions. Voice tone and rhythm. Physiological sensors. Example: emotion AI in mental health apps. Affective computing is a branch of artificial intelligence, AI, that focuses on the design of systems and devices that can recognize, interpret, process, and respond to human emotions. Applications of affective computing. Healthcare, AI-powered mental health apps, for example, Wobot. Replica. Education, emotion-aware tutoring systems. Customer service, emotionally responsive chatbots. Automotive, emotion detection in drivers to prevent fatigue. Gaming and VR, adaptive experiences based on user mood. Data-driven chart showing emotion detection accuracy by modality in. Affective computing, social robotics, emotional machines in. Action. Robots designed to interact socially with humans. Applications in elder care, autism therapy, education and customer service. Case study, Pepper, Paro, Moxie robots. Cognitive collaboration, human plus AI teams. Beyond automation, AI as a collaborative partner. Empathy enhances co-working dynamics. Example, AI assisting in crisis counseling, education feedback. Emotional intelligence in machines. Recognition of emotional cues. Adapting responses based on mood/context. Personalization in AI agents, chatbots, tutors. Empathetic AI in healthcare. Understanding patient distress, anxiety, or pain levels. Companion robots. Empathetic virtual health assistants, for example. Wobot, Replica. Common categories and examples of HCAI tools. 1. Globe with Meridian's explainable AI XAI tools. These help users understand why an AI system made a decision. Shapley additive explanations. Lime, local interpretable model agnostic explanations. IBM AI Explainability 360. Google's What If tool. 2. Brain emotion and empathy detection. These tools analyze human emotional and behavioral states. Affective SDK, automotive and video emotion recognition. Open Face, facial behavior analysis. Beyond verbal, voice tone emotion AI. Replica AI, conversational empathy based AI. 3. Human AI interaction design platforms. Books. Used to build AI systems that interact naturally with people. Google Dialogflow Conversational Interface Builder. Microsoft Azure Bot Service Multi-Channel Chatbots. Rasa Open Source Conversational AI with NLP. 4. Locked with Key Ethical AI and Fairness Tools. These help mitigate bias, promote fairness, and assess risk. AI Fairness 360 Toolkit IBM. FairLearn Microsoft. TensorFlow Model Analysis, TFMA Fairness Analysis. AI Incident Database Tool for AI Risk Benchmarking. 5. Handshake Human AA Collaboration Platforms. Support co-working between humans and AI systems. AutoAI Real-Time Transcription plus Summarization. Grammarly AI Writing Assistant with Adaptive Feedback. GitHub Copilot assists programmers while coding. Dovetail/Notion AI, helping with research analysis or writing. The future of HCAI is not just smarter machines, but more humane intelligence. It will shape a world where AI empowers, not replaces, listens, not just executes, collaborates, not controls. Right arrow. The next frontier is ethical, empathetic, and explainable AI that amplifies the best of humanity. Conclusion. B. As such, Niederman, human-centered artificial intelligence, reliable, safe, and trustworthy, ICM trans. Interact, Intel, Syst, Evolve, 10, No. 4, pages 1 to 33, Oct. 2020. DOI 10.1145/3,380,750. DARPA, Explainable Artificial Intelligence, XAI, Defense Advanced Research Projects Agency, 2021. Online. Available. https://www.darpamil/program/explainable artificial intelligence. UNESCO. Recommendation on the Ethics of Artificial Intelligence, Paris, France, 2021. Online. Available. https://unesco.org/r/48223/EF381137. European Commission, Ethics Guidelines for Trustworthy AI, Brussels, Belgium, 2023. Online. Available. https://digitalstrategies.eu/en/library/ethics guidelines trustworthy AI. Allied Market Research, Affective Computing Market by Component Technology, Industry Vertical, Global Opportunity Analysis, and Industry Forecast 2022 to 2030, 2023. Online. Available. https://www.alliedmarketresearch.com/affective computing market. Accenture and MIT Sloan, Human Plus Machine, Reimagining Work in the Age of AI, Accenture Strategy, 2022. Online. Available. https://sloanreviewmit.edu. Stanford University, the AI Index Report 2023, Stanford HAI 2023. Online. Available. https://iindex.stanford.edu. MIT Media Lab, Emotionally Responsive AI Tutors Improve Learning Retention, i.e. Trans. Learn. Technol. Evolve. 1501, pages 12 to 21. 2021. Online. Available. https://explore.org. Carnegie Mellon University, Intelligent Tutoring Systems and Emotional Feedback, CMU Press Brief, 2022. Online. Available. https://www. IBM Research, XAI in Oncology Diagnostics Using Visual Heat Maps, IBM Watson Health Case Study, 2023. Online. Available. https://research.ibm.com. World Economic Forum, Human-Centered Artificial Intelligence for Public Sector Innovation, Geneva, Switzerland, 2023. Online. Available. https://www.waforum.org/reports. McKinsey Global Institute, The State of AI, Accelerating Adoption with Trust and Transparency, McKinsey & Company, 2023. Online. Available, https://www.mckinsey.com/NGI. References.